these rational polynomial inequalities, well, all the inequalities, this unit is super important, not so much for grade 12, but when you get into calculus, because you use this when you're doing graphing analysis and stuff with derivatives when you first get into calculus. So I know that we've done quadratic inequalities, and there's nothing different here. If you can simplify an RPE like we did in the last unit there, you'll find this pretty straightforward. So I got the steps written out here. Simplify, so add, subtract, multiply, whatever it is, all on one side. So what I mean by that is we've got to make sure that it equals 0. So it's less than or greater than 0 on the one side. If that's done, then you can factor both the numerator and the denominator. Remember from the RPEs unit that our x-intercepts came from the numerator, almost read that, and your vertical asymptotes, or your non-permissible values, as we called them in that unit, come from the denominator. Okay, and from the graphing of those, you'll see that we're not going to graph these. We don't need to. We did that already, so we're going to ignore what the graphs look like altogether. We don't care. So then the third thing we're going to do is we're going to take all those x-intercepts, all the vertical asymptotes. We're not worried about holes in this. If something cancels out, we're not 100% concerned about it at all. So we're going to put those on a number line, and we're going to do the same thing we did with quadratic stuff. We're going to check the regions for signs, and then we'll just state our solution. So this is a pretty straightforward question. It's just one RP. The top is already factored, so I can say x plus 3 over. The bottom's the difference of squares, x minus 2, x plus 2. And then the less than 0 is even who cares, because really we don't even look at this until the very end when we're looking for what should our solution say. So at the very end, we're going to get our answer where it says less than 0, so negative numbers, right? So if our region's negative, that's where our solutions come from. Okay, so now from the top, I can say my x-intercept, x equals negative 3. And from the bottom, vertical asymptotes, I can say x can't equal 2 and x can't equal negative 2. Now you say, well, why are you saying can't equal? Well, it's a vertical asymptote, so the graph isn't going to cross there, but it changes from being below to above the x-axis a lot of time on vertical asymptotes, so you'll see how that happens. And then the can't equal, for instance, if I put a less than or equal to sign, these can't equals are super important then, because I wouldn't be able to put the equal sign in my final statement of solution. Okay, I'd have to just say less than or greater than, not equal to it. Okay, so I'm going to erase all that. Go back to the question. Okay, so we factored both top and bottom. We solved, right? I guess I never really put that. I should have said factor the numerator completely. We use these factors. Oh, no, we did that to find the x-intercepts, vertical asymptotes. I guess that's this step right here. And then we got to plot these on a number line. So I'm going to take this to a number line like this, and I'll say negative 3, negative 2, and 2. I'm going to check my regions. So I got to pick a number that's not on my number line. So obviously 0 is the easiest one all the time. So I take a 0 and I plug it in for x here and here and do a little mental math. I get 0 plus 3 is 3 divided by 0 minus 4 is negative 4. So I get a negative sign in between there and there. We know from the quadratic stuff, and it's not going to be a big surprise to find out that these alternate almost all the time. There are rare occasions. In grade 11, I don't give you any of the rare occasions. Things like holes come into play, like points of discontinuity. If you've got a weird bounce or something, a parabola, but 99% of the times, it's just going to alternate the signs. So you can assume that for right now. When we get into grade 12 and calculus, I'll dive into that a bit more. So we've checked our regions. All we checked is the one. We know the other ones alternate. So now I can state my solution. Well, that, remember, comes back over to this guy. The inequality says, where's this graph below the x-axis? Where's this graph going to have negative y values? Well, we can see it in this region right here. It's negative. And in this region right there, it's negative. So, put arrows on my number line just so I can show less than negative 3 and between negative 2 and 2. So you heard me say less than negative 3 and between negative 2 and 2. So I've got a splitter and I got a betweener statement all in one. So I'm going to go like this. I'm going to say my solution is, fancy bracket, x is less than negative 3. Because I'm not worried about the equals to, remember, you can see I don't have an equals to, so I'm not putting equals to. Or, so there's my splitter side. Now I got to do my betweener. Negative 2 is less than x, which is less than 2. Fancy bracket. And there is my solution for this rational polynomial inequality. Okay? So we're going to do a couple examples like this, and hopefully they just become one after the other. So here's one that's not simplified yet, so we'll quickly simplify this. I notice they're already common denominators, so I don't have to worry about that. It's just x plus 1, and then 3 minus 5 is negative 2 is greater than 0. Let's make this one greater than or equal to 0, so you can see how this will work. Okay, so I got to go and solve this. Well, the top factor, done. There's no x's up there, so I don't even have any x-intercepts on this graph. I have a vertical asymptote of x can't equaling negative 1, right? So there's my vertical asymptote. I've only got 1 point, so I plot it on a number line. Negative 1. I'm going to test my region. I'm going to go and test 0. 0 somewhere in this region. So I plug a 0 in, I end up with a negative. Obviously, that one's positive then. Well, not obviously, but we can assume that right now. Okay, we'll get into that again later. So now, let's go and answer our question. Because we know what signs our region are, so our y values are positive over here and they're negative over here. And we are looking for, based on the inequality, it says greater than 0, so positive numbers. So that is that way, towards the positive symbol, right, representing our y values. So now I can state my solution. Fancy bracket, x is less than, I want to put equal to, but from earlier we found out x can't equal negative 1, so we don't say equal to 1. If it was allowed to be, if it was an x-intercept, we would put the equal sign, but we can't here because it's a vertical asymptote, is less than negative 1. So some of your solutions are fairly straightforward and easy, like this one. Okay, let's go try one more. Okay, now we don't have a 0 in this case, so I'm going to minus, or I shouldn't say minus, but bring one of the fractions over to the other side so it can be equal to 0. Like I said earlier, you have to have it simplified so that it equals 0. So let's bring that 1 over. Like so. Okay, and maybe we can do an equals to on this question too. Let's change that to that so you can see how it'll change. It'll change things drastically in this question. Okay, I got to get common denominator, so I'm going to times this side by x plus 2, top and bottom. This side by x minus 2, top and bottom. So now when I get this, I get 3. I'm just going to simplify this a bit here right now. So 3x times x plus 2, I get 3x squared plus 6x. And then that minus 1 into the x minus 2, so minus x plus 2 all over. And you never have to multiply the bottom out because you want to factor it in the end anyways. So I just always leave it simplified out like that. Less than or equal to 0. So now when I simplify the top, we have a trinomial difficult, it looks like. Okay, so that's just step one. Simplify, right? Now, I'll move it up here, and we'll factor that. That's a trinomial difficult, product of 6, sum of 5, so 3 and 2 gives us x plus 1. And you can do this on scrap paper if you want. 3x plus 2. Go ahead and factor the trinomial, or you can just trust me that that's what it is. I've had people trust me before. Less than or equal to 0. Here we go. So now I've got everything factored. I can go and state my x-intercepts and my vertical asymptotes. So I got x can equal negative 1. Two-thirds. I've got x can't equal negative 2, and x can't equal 2, because those are vertical asymptotes. Okay, so we've got all of our solutions. Let's plot them on a number line. So negative 2, negative 1, negative 2/3, and 2. Test my regions. I'm going to pick the 0 every time if I can. So in this case, I'm going to go back in, and people wonder, which one should I go into? It doesn't really matter, but you might as well go and put it into this one, because then you can get what it is, whether it's 0, rather than putting it into the first one and then subtracting it over or adding it over, whatever the case is. So I'm going to put a 0 in. So I get 0 divided by negative 2 is 0. Subtract 1 over 2. So 0 minus 1/2 is a negative. Now, sorry about that. Alternate my signs, assuming that there's nothing fancy or special about this stuff. There it is. Let's put in our solution now. It wants less than or equal to 0. Okay? So you always go back to that inequality where it's comparing itself to 0. So less than or equal to 0, that is towards negative numbers, and our y values is what we're talking about. So where's y negative? Well, y is negative where we tested the region and it came out negative. So in this case, it looks to me like I've got two betweener solutions. So I'm going to write this down as negative 2. I cannot equal negative 2. Remember that. So I don't say less than or equal to. I just say less than x, which is less than or equal to negative 1, because I can equal negative 1. Okay. Comma. It's not a real good comma, but there. Try that. That's better. Negative 2/3 I can equal to x, but I cannot equal 2. Fancy bracket. So there is your two solutions. You don't need those round brackets. I don't know why I put those round brackets in, but there's your two betweener solutions. So I hope that makes sense on the less than or equal to thing. And I mean, I maybe discussed it with quadratic inequalities too, but there's rational inequalities, so that should take care of this unit. There's other ones too that you end up doing later on, but the three that we do in this unit are pretty much cover everything that you need to know.